Hi, welcome to my video on finding the value of an unknown when the function is continuous. Find the value of the unknown. We have three problems here. Let's work out the three of them. Find the unknown value when continuous. So we have the f of x equals 4x minus a when x is greater than 1, negative x plus 3 when x is less than or equal to 1. We want to show it's continuous or find the value of a when x is 1. So the limit of the f of x is as x approaches, is continuous at 1 on the positive side. So the limit of that's 4 on the positive side, greater than 1, is 4x minus a as x approaches 1 on the positive side. So that gives us, that value is at 1, so it's 4 times 1 minus a, so that's 4 minus a. Now we look at the limit of the f of x as x approaches 1 on the negative side, and that's when you approach 1 on the negative side, we have a negative x minus 3. Sorry, negative x plus 3 as x approaches 1 on the negative side. So 1, so that's the negative of 1 plus 3, so that's a 2. So if it's continuous, this limit on the right is equal to the limit on the left. So that means 4 minus a must be equal to 2. So negative a equals 2 minus 4. Negative a is negative 2. And multiply by negative 1, so a is 2. So when a is 2, the left side and the right side both have the same value. So you can check it out if you want. You can check it out. So let's take this, when a is 2, so we have a 4x minus 2. So when we put 1 in here, we're just checking, we get a 2. And the other side is negative x plus 3. So when we put a 1 in here, we get a 2. So again, when this a is 2, both left and right limits have a value of 2. And they're continuous. And when it's equal to 1, we get a 2 is defined. So the limit on the left is equal to the limit on the right. And it's defined at 1 because 1 gives us a 2. So hence the value of a that makes this f of x continuous, the a has to be 2. Now, number 2, we got a p of x, and we got this long binomial here. X is greater than or equal to negative 3. K squared times x squared plus 2 times kx plus 10. And if x is less than negative 3, we got a negative 8 over 3 k squared x plus 1. And we want to show that it's continuous at x equals negative 3. So if it's continuous at x equals negative 3, we got to find its value of k. So let's take our time, work it out. And again, this is the p of x. And we're going to x approaches negative 3 on the right side. So on the right side is greater than, so that's k squared x squared plus 2kx plus 10 as x approaches negative 3 on the right side. So x is negative 3, so we got a k squared, negative 3 squared. X is negative 3, so we're subbing it in. And that gives us 9, so there's a 9k squared minus 6k plus 10. So we're trying to find this value of k. So let's look at the limit as the p of x approaches negative 3 on the left side. So when we approach, and on the left side, the limit, as x approaches negative 3 on the left side is less than, so this is a negative 8 over 3k squared x plus 1. So we're putting a negative 3 in the place of x, so negative 8 over 3k squared. X is negative 3 plus 1, so we multiply, the 3's cancel out, so that gives us an 8k squared plus 1. 8k squared plus 1, just check it out. Negative times negative positive, 3's cancel, so it's 8k squared, okay. So we know now, because it's going to be continuous at x equals negative 3, that means that the limit on the right, which is k, 9k squared minus 6k plus 10, is equal to the limit on the left, which is 8k squared plus 1. Notice we got a quadratic, so we'll move k squared, move the 8 over, move it in descending order. So that gives us a k squared minus 6k plus 9 equals 0. A quadratic, so let's see if it's factorable. If not, we got to use the quadratic formula. K squared is k times k. Factors of 9 to give us 6 must be 3 and 3. Product is plus 9, so it got to be 2 pluses or 2 minuses. Because the sum is negative 6, it got to be negative 3, negative 3. Notice we got k minus 3 equals 0 twice. That means k is equal to 3, k is equal to 3. So the value of k that we put in here to make this continuous at a negative 3 is 3. Again, you probably 3 seems to be the number that I'm working with all the time. I'm normally not like that. Anyway, so when k is 3, this p of x is continuous at the negative 3. Now let's do another one. H of x is equal to x over 4 minus k over 4 between 1 and 5. And the sine of x times pi over 2 between 5 and 9. So we want to show, we want to find the value of k that will be continuous at x equals 5. So the limit of the h of x as x approaches, we're approaching 5. So I like to do the right side. So what is the right side? Well, let's have a look. The right side of 5, this is the right side right here. So it's the sine of x times pi over 2. And as x approaches 5 from the right side, again, just to verify, the right side, 5, 6, 7, 8, so that's the right side. This is the left side. This left side is smaller than 5. So when you work that out, we put 5 in, we get the sine of 5 times pi over 2. So sine of 5 pi over 2 is just, so if, the way I do it, I think of it as 5 pi over 2. Pi over 2 is a 90. So that's 5 90s. So 5 90s is, and I draw a circle right here now. Just draw a little circle. So if you, 5 pi over 2 is 5 90s. 1, 2, 3, 4, 5. So the sine of 5 pi over 2 is the same as the sine of pi over 2. And the sine of pi over 2, this is 0, 1. And the sine of pi over 2 is 1. Sine of 90 is 1. So that's the right side. So what about the left side? So the limit, the h of x approaches, x approaches 5 from the left side. So that limit, h of x as x approaches 5 from the right side. Oh, I got h of x there. So I should have, sorry about that. This is x over 4 minus k over 4. So when I put 5 in here, I get 5 over 4 minus k over 4. So that can't be simplified any further. I can do 5 minus k over 4. I can do that, make it one fraction instead of two. But the limit on the right is equal to the limit on the left. So that means 5 minus k over 4 is equal to 1. And another name for 1 is 1 over 1. So when I cross multiply, you get 1 times 5 minus k is 5 minus k. 4 times 1 is 4. So let's go up here. So that gives us negative k is 4 minus 5. Negative k is negative 1. Multiply by negative, or divide by a negative number, k is 1. So I put a little trig in this, but not too heavy. So the value of k, so x over 4 minus 1 over 4, and that they're equal. So if you put a 1 here and work this out for 5, you will get the same value for both of them. So that means the limit exists, so it's continuous. So when k is 1, this is continuous at x equals 5. When k is 3, this function is continuous at negative 3. When a is 2, this function is continuous at 1. So some extra examples there, finding the unknown values, which is always a question on your exams when you get this unit. Click on the button if you like my video, and subscribe button, click on that. And also, you can visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.